and then I'll minimize that, and then I'll just go on my merry way. So now it's recording, so if you want to go back and listen to any of this later, you can. So that's Blackboard Collaborate. Anybody got any questions at this point? Okay, we have to go through these two videos, which you might have already heard. So we got to do the safety video and the timeline video. So let's just go ahead and get those out of the way. Actually, I'm going to pause my recording because we don't need to do that. Okay. So we're not going to spend a huge amount of time on chapter 1. I'm just going to read you the topics. So the title for chapter 1 is The Art of Problem Solving. And the first thing we're going to talk about is two types of reasoning that are used in solving problems, inductive and deductive reasoning. And basically, you're just going to be responsible for telling whether a series of sentences is an example of a deductive reasoning or inductive reasoning. And we'll give some examples, because a lot of math, the ideas behind math is using reasoning in one of the two ways to solve problems. Ultimately, we're trying to solve a problem to some extent. So you know, math, for you guys, for non-math people, what's the purpose? Why do you have to take a math class besides just broadening your experience? And a lot of it has to do with just being able to logically approach a problem of some sort. I mean, no matter what kind of job you have, somebody's going to say, you know, I need for you to do this, and you've got to figure out how to do that. And how do you do it without just having a book that you go to and say, step 1, step 2. You know, sometimes you have to do thinking in terms of figuring out how to do stuff. So just having a logical approach to solving any kind of problem. We're going to use numbers here for the most part. Now there's a section on applying inductive reasoning. That's the second section. Third section is some strategies for problem solving, which you could spend the whole semester on. And section 4 is basically looking at graphs, using graphs to estimate stuff. So that's the first chapter. After that, we're going to talk about logic and set theory, which you may not have had set theory before. The whole idea there is logic also applies to computer programming, which, again, you guys may not become computer programmers, but just having an idea of what's behind the whole idea of programming and computers. It's good to know the background. So that's kind of, and then we'll talk a little geometry review. Okay. So the first thing we're going to do is we're going to just talk about deductive, what is inductive and deductive reasoning. And, you know, sometimes I'll just say it's in your book. So that, and the reason, so I would suggest you pay more attention, not feverishly write stuff down. What you should probably write down is examples that you do in class. Things like terminology. You have your book. I allow you to bring in a cheat sheet for tests, so you're not going to have to memorize stuff. So it's more a matter of understanding things. So, so in this case, I'm not writing the definition down, and I would just say, write inductive reasoning, deductive reasoning to remind you when you read the book that's important. Okay. So inductive reasoning is characterized by drawing a general conclusion, which is called making a conjecture, from repeat observations of specific examples. The conjecture may or may not be true. So this is kind of like running an experiment. So you run an experiment, or you could run a formal experiment, or you could just observe people. Just observing nature is It's an experiment, but it's just a natural experiment. So, you know, you could, red sky in the morning, sailor's warning, or red sky at night, sailor's delight. That's kind of what that is. Somebody, to get to those conclusions, somebody observed, hey, every time I see a red sky in the morning, it seems like it's going to rain, or it's going to be some weather problem. So the conjecture is that when you see a red sky in the morning, you're going to have some kind of weather situation. And they didn't just make that up. Somebody made observations, and after they made enough observations, they made that conjecture. And we know that that conjecture maybe has some truth to it, but it may not be entirely correct. So the conjecture that you come up with may be right or wrong. Even with a more formalized experiment, every week there's some new study out that contradicts a previous study. In those cases, somebody's made a conjecture and statistically said this is true, but then it turns out not to be true. So it doesn't always have to be true. So you basically do a lot of experiments to make a general conclusion. That's inductive reasoning. The other case is you use some kind of general principle to then deduce specific results. So an example of that would be, what's a good example of that? Say physics. I use physics examples. You know, there are laws of physics. And if I said, so here's a general, force equals mass times acceleration, which you may remember from some high school science class you took. So that is a general principle. And then you could say, well, if I apply a force of 5 newtons to this book that weighs, has a mass of 1 kilogram, then Newton's second law is going to tell me that the acceleration is some value. So I'm applying a general principle to a specific example. So they kind of go, one goes specific examples to a general conclusion, inductive reasoning. Going from a general principle to a specific example is deductive reasoning. So here's a couple of examples. So what I have here is I have 3 triangles. And so what I do is I measure the 3 sides of these 3 triangles. So I'm actually, getting a tape measure out, and I'm going, okay, here's this side is 6, this side is 6. I measure this side. It turns out it's 6 times the square root of 2. I go measure this triangle. I do the measurements, and I come up with 3 examples. So those are the 3 specific experiments that I'm running. And then I say, well, what if there's anything I can, any kind of mathematical relationship I can come out with relating this length of the sides, the length of the 2 sides to the length of the hypotenuse, and hopefully you guys vaguely remember something called the Pythagorean theorem. And so I would use inductive reasoning to come up with this result. So I'd say a squared plus b squared equals c squared. And for those 3 cases, it works. And so I could then say, in general, any triangle, that's true. So I'm using the experiments to come up with a relationship. So that's inductive reasoning. But you can go from the other direction. There are mathematical ways of proving, there's like hundreds of mathematical ways of proving that if you have a right triangle with sides A, B, and hypotenuse is C, that there actually is a mathematical way of, it's not I'm doing experiments here, I'm doing a mathematical proof. And so in this case, I start with a squared plus b squared equals c squared. That's my general conclusion, my general principles based on a proof. And therefore, then I can say, well, if I go to a specific triangle, then on that specific triangle, any triangle, if I measure the 2 sides, then the third side, the hypotenuse, should be equal to the sum of the square of the third side. The hypotenuse should be the sum of the squares of the two. So I'm going to a specific example. So that's deductive reasoning. So the question you have to ask yourself when presented with, is this inductive or deductive reasoning, is, am I running a lot of experiments to come up with a general conclusion, or am I starting with a general principle and applying it to a specific example? That's the question you have to ask yourself. So this is a side. I decide to do side things just when I think they're interesting. Some of you may find it interesting, some may not. And Google is your friend when it comes to this kind of things. So you can go online and just search for Pythagorean theorem proofs, and they actually show some of the proofs, including the original proof by the Pythagoreans. But I'm not going to show, obviously we're not going to go through all these proofs, but I just wanted to show you. So right there are 117 different ways of proving that the Pythagorean theorem is true. So if you're a math person, it's kind of interesting looking at that, because they're all, some of them are pretty interesting. Some are geometric, some are algebraic, and I've looked at a few of them, but it's, you know, just looking for my power cord before it shuts off.